Okay, so students, today we will discuss how to find PI by method of variation of parameter. Okay, so we know that our general equation of second order differential with constant coefficient, that is d2y dx2 plus p1 dy dx plus p2y equals to some function of x, for which we know how to find CF, right? So this time, suppose if our CF is C1 y1 plus C2 y2, where y1 and y2 are Li solutions, then Pi is some u into y1 plus some v into y2, where u equals to minus integration y2x by Wronskian w and v equals to integration y1x by Wronskian w. Now what is the Wronskian? Wronskian is y1 y2 y1 dash y2 dash. If this Wronskian not equals to 0, then we say y1 and y2 are linearly independent. Linearly independent solution, that means Li solution. Okay, so students, let us take one example. Let us discuss about this question. d2y dx2 plus 4y equals to sine 2x. Suppose we have this. Now we find the CF first. So let us take y equals to e to the power mx is a trial solution. Now if it is a trial solution, then we know in place of d we are going to put m, and in place of d square we are going to put m square for finding the auxiliary equation. Therefore auxiliary equation is m square plus 4 equals to 0. So m equals to plus minus 2i. Now as we have value of m as complex number, therefore our CF will be C1 cos 2x plus C2 sin 2x. Therefore students, if I compare it with C1 y1 plus C2 y2, therefore our C1 y1 is cos 2x and y2 is sin 2x. Now let us find Wronskian first, because if Wronskian not equals to 0, then only these solutions are independent solution, and if we have independent solution, then only we can proceed further. So y1 is cos 2x, y2 is sin 2x. Now differentiation of y1, that is minus 2 sin 2x, and this is 2 cos 2x. So therefore if I multiply, it is 2 cos square 2x plus 2 sin square 2x. If I take 2 common, this is cos square 2x plus sin square 2x, and we know value of cos square a plus sin square a, that is 1, so is equals to 2, not equals to 0. Therefore we can say that y1 and y2 are Li solution, that means linearly independent solution. So as y1 y2 are linearly independent solution, therefore our Pi is, in place of c1 put u, so u y1, and in place of c2 put v, so v y2. Now our work is to find u and v. Now what is u? Formula for u is given this, minus y2 x by Wronskian. So minus integration of y2 is sine 2x, x means the given function. What is the given function? We have sine 2x as given function, so therefore sine 2x by Wronskian is given 2, okay, dx, that is minus half integration sine square 2x. Now see, if I multiply 2 here, then it will become 1 by 4 into this. Now minus 1 by 4, in place of 2 sine square 2x I am writing 1 minus cos 4x dx. Okay, so now if I integrate, it is minus 1 by 4 into integration of 1, that is x, minus integration of cos 4x, that is sine 4x by 4. Okay, so that is our u, and v equals to integration. Let us see the formula again, that is y1x by Wronskian, this one. So y1x by Wronskian, that is y1 means what? y1 is cos 2x. Okay, so cos 2x into the given function sine 2x by Wronskian, that is 2 dx. Now see, if I write 1 by 4 and multiply 2 here, that is 2 sine 2x into cos 2x dx, which is 1 by 4 integration sine 4x dx, that is minus 1 by 16 cos 4x. Therefore our Pi is minus 1 by 4 cos 2x plus 1 by 16. Now let us multiply cos 4x with that, so we will get cos 2x sin 4x minus sin 2x cos 4x, which is minus 1 by 4 x cos 2x plus 1 by 16 sin 2x. Therefore our general solution is CF plus PI, that is C1 cos 2x plus C2 sin 2x plus minus 1 by 4 x cos 2x plus 1 by 16 sin 2x. Okay, let us take another example, students. Example 2. Suppose this time we have d2y dx2 plus y equals to sec cube x tan x. So let us first find CF. So y equals to e to the power mx is a trial solution. Now if it is a trial solution, then in place of d we have to put m, and in place of d square we have to put m square to find auxiliary equation. Therefore the auxiliary equation is m square plus 1 equals to 0. Therefore m equals to plus minus I. Therefore CF equals to C1 cos x plus C2 sin x. Now let us take Pi as u into some cos x plus v into sin x. So our work is to find u and v. These are two unknowns. Now u is nothing but minus y2x by Wronskian dx, and v is minus integration y1x by Wronskian dx. Okay, so what is our y1? According to this our y1 is cos x, see, and y2 is sin x. Okay, so we have our y1 y2. Let us find Wronskian. Wronskian is y1 y2 y1 dash y2 dash. So therefore it is cos x sin x minus sin x cos x. Therefore cos square x plus sin square x equals to 1, not equals to 0. Therefore y1 and y2 are linearly independent solution. So now we can proceed. Now let us find u first. So u equals to minus y2. y2 is sin x. Okay, so sin x, and what was our given function? Given function x was sec cube x tan x. Okay, so let us write sec cube x tan x by Wronskian is 1 dx. That is minus integration tan square x into sec square x dx, because we know if I take one sec with sine, that is sin x by cos x, nothing but tan square x. Okay, so students, I am taking tan x equals to z. Therefore sec square x dx equals to dz. So this will reduce to minus integration z square dz, which is minus z cube by 3, that is minus tan cube x by 3. Now v equals to integration cos x sec cube x tan x by 1 dx by Wronskian. So equals to, this is tan x into sec square x dx. One sec will cancel out with cos. Let us take tan x equals to z. Therefore sec square x dx equals to dz again. Therefore it is integration z dz, that is z square by 2, that is tan square x by 2. Therefore our Pi equals to minus tan cube x by 3 into cos x plus tan square x by 2 into sin x, which is minus 1 by 3 tan square x into sin x plus half tan square x sin x, which is minus 1 by 6 tan square x sin x. Therefore students, the general solution is CF plus Pi. Now CF was C1 cos x plus C2 sin x, and Pi is minus 1 by 6 tan square x into sin x. So therefore this is minus 1 by 6 tan square x sin x. Okay, so students, today up to this, we will meet in our next class.